In this interactive advanced concept presentation, I'll be explaining what type of nuclear chemistry is needed for a nuclear bomb. What are nuclear bombs? Nuclear arms are weapons of mass destruction that use nuclear energy to create an explosion. Atomic and hydrogen bombs are usually thought to be the same thing. They are incredibly similar, however, there are a few differences. Nuclear weapons are measured in TNT equivalent. TNT is an explosive that is pretty well known. A certain amount of TNT is required to produce the same amount of energy to create a nuclear bomb, which is expressed in kilotons and megatons. The two most popular bombs are the Little Boy and Last Fat Man, which cause extreme chaos and damage. The atomic bomb looks like an elongated, rounded torpedo. In order for it to become an explosion, the inside of the bomb must contain a chain reaction of fission and heavy nuclides. The usual metal that is used is uranium-235. The content of 235 isotope in uranium needs to be at least 80%. If something does go wrong with this process, there will be a fallback. Another bomb that is made is a plutonium bomb, which is based on the isotope 239. However, plutonium is rarely found in nature, so usually it has to be made artificially. A nuclear explosion occurs because of a critical mass. When critical mass is reached, a nuclear decay reaction is formed with the release of energy. Nuclear bombs need between 4 and 5 critical masses of matter to create the kind of damage that is hoped of a nuclear bomb. In the hydrogen bomb, energy is released due to thermonuclear fusion. The elements required include deuterium and tritium, along with other heavy elements. However, the main substance is lithium hydride. The detonation is carried out by an integrated nuclear device. When the detonator is activated, energy is released. This is what triggers an explosive thermonuclear reaction inside the bomb. Hydrogen bombs are dangerous because they have no limit. There could be a hydrogen bomb that has enough power to wipe out the process is shown in the image here. First, chemical explosion compresses fission fuel to initiate fission. Then X-rays from primary are reflected by causing heat and foam. 3. Foam, now plasma, compressed secondary, fissionable spark plug ignites. And then 4. Fuel, fusion fuel ignites. Radiation is the result of a nuclear bomb reaction. There are 3 types of radiation: alpha, beta, and gamma. Alpha radiation does not do much harm, though it does a little. Beta radiation is a bit more dangerous than alpha. The results of beta exposure include radiation burns and cataracts. Gamma radiation, however, is the most harmful, and there isn't much that can protect us from it other than thick layers of lead or concrete. Some outcomes of exposure to gamma include radiation sickness, cancer, and even gene mutation. Thank you for watching. I hope you learned a bit more about nuclear bombs and the effects of them.